All right, today we're going to look at how you can evaluate trig integrals that have this form of sine and cosine in the integral where there's exponents on both. What we're going to do in order to help us is use um, our Pythagorean theorem identity here, that sine squared plus cosine squared equals 1. So what we're going to look at is if you have cosine with an odd power, we're going to kind of split them up, save one of those cosine factors, and then substitute in cosine squared being equal to 1 minus sine squared for the remaining factors. If we have a one that's where sine is odd, where sine has the odd power, we're going to make a very similar substitution, except we're going to do it the other way and leave substitute the even powers of sine using sine squared equals 1 minus cosine squared. So using that same Pythagorean identity, just changing it to help us depending on what the problem looks like. All right, so let's try one out here. We want to evaluate cosine cubed x. So what we got to see here is that we have an odd power up here of cosine. So when you have that, you want to take one of those cosines out. So we're going to think of it as cosine squared x times another cosine x. It's still 3 cosines like we started with. Then we're going to substitute in for the cosine squared. We're going to change that into 1 minus sine squared using that Pythagorean identity. Okay, now this doesn't maybe look like it made it easier, but it does, because what we're going to do now is do a substitution. We're going to substitute u for sine, because what that's going to do then is when we take the derivative, we get cosine, and that's going to knock out that one cosine factor that we left. That's why we left one of those. So that'll turn into our du, and sine will turn into our u. So now our integral becomes 1 minus, and it's squared here, so it's going to be u squared. And then the cosine x dx all turns into our du. Now we should be able to integrate that. That's an easy one there. It's just using our power rule. So we got u as the antiderivative of 1. And here we got to go up to u cubed, which means we got to put reciprocal of 1/3 in front of it. Plus could be some possible constant. Last step now, like we always do with substitution, substitute back in. So we want to substitute sine back in for u. So we got sine x minus 1/3 sine cubed plus c. And that would be the antiderivative of cosine cubed. All right, let's take a look at a different one. Next one, we have sine to the 5th times cosine squared. We want to look at which one is the odd one. Well, you can see here that odd one looks to be the sine one. So on this one, we're going to separate and leave one of those sines. So we're going to think this as sine to the 4th now, x times cosine squared, and I'm saving one of those extra sines. So we still got 5 sines here. It's just that we separated one of them out. Okay, now we're going to substitute in for those remaining sine of x's. So we know what we know here is that sine squared equal 1 minus cosine squared. So what we got to think of, how many sine squareds do we have there? It would be like 2 of them because it's sine to the 4th power. So if we substitute that in, that's going to become 1 minus cosine squared. That would be for one sine squared, but we got 2 of them, so this would end up being squared here. Times another cosine squared that we already had there, times our sine x. Okay, now we're going to do a substitution like we did on the last one. So on our substitution here, this time we're going to do cosine of x, derivative being negative sine x. Okay, so when we make this substitution, we got the sine x dx there, but this is going to end up being negative du here. So we are going to end up with an extra negative on this one. All right, so let's make our substitutions. I'm going to put that negative out front. This is going to turn into 1 minus u squared squared. Cosine squared is going to turn into u squared. And then my sine x dx turns into my du with that negative that I already put out front. Okay, now this one, little bit, not so quick to evaluate like our one before. This one is going to be solvable, but we're going to have to do a little bit of algebra first here to get this into a form that's easier to find the antiderivative. So we are going to actually have to multiply this one out. Let's think of this as 1 minus u squared times another 1 minus u squared. We're going to FOIL that, and then we'll have to multiply that final u squared there. So if we FOIL that out, we're going to get a 1 minus u squared minus another u squared, so minus 2u squared. And then negative u squared times negative u squared is going to be positive u to the 4th power times that additional u squared. So one last round of algebra here, then we'll find our antiderivative. So if we distribute that u squared now, we got u squared minus 2u to the 4th plus u to the 6th. Remember, you add exponents when multiplying. Now this is finally in the form where we can find that antiderivative without hopefully too much trouble here. This is going to be 1/3 u cubed. Got to go up a power here too, so u fifth. Reciprocal by 1/5 times 2 would be negative 2/5. Here we got to go up to u to the 7th with our reciprocal of 1/7 plus a possible constant here. And then last thing, you got to distribute that negative sign through. And we have to substitute back our cosine to get our final answer. So final answer is going to be negative 1/3 cosine cubed. This next one is going to turn positive because we're distributing that negative sign through. 2/5 cosine to the 5th. And again, got to distribute that negative sign, so this one's going to turn negative 1/7 cosine to the 7th plus our constant. There's our antiderivative on this one. So that's kind of that process that you're going through. Why don't you pause the video and try this one on your own and see what you come up with. Now it does have, notice it does have limits on there, so you're going to have to, once you do the substitution, find the limit there. All right, let's see how you did here. This one looks like the odd one is on the sign, and so that's the one we're going to want to split up here. We want to think of it as sine squared, cosine squared, and the remaining sine x that we pulled out. Actually, looks like we're using theta here, so I should change and use the same variable. So on this one, since sine's the one that we pulled out, that then we want to substitute or do our trig sub identity with that one. So it would be 1 minus cosine squared that we're putting in place of that. All right, so that tells us here, since that's what we got is the cosine, that should be our substitution here. So u equals cosine theta, which means our derivative is negative sine theta, and we're going to end up with that extra negative in this one again. So when you substitute, going to put that negative out in front. This is going to turn into 1 minus u squared. This is going to be u squared. The sine theta d theta turns into our negative du or sorry, du, and our negative's already out front there. And then this one being a definite integral, you want to make the substitutions on those limits. So I would also change those at this point too. So you'd want to see what is u at pi over 2 going to turn into. So that u at pi over 2 is going to come out to be cosine of pi over 2, which is going to turn into 0. And then u at 0 means we're doing what's cosine 0 and cosine, whoop, not cosine theta, cosine 0. And cosine 0 is 1. That's right. On our x-axis on the unit circle, so that'd be 1. So these are going to change over here to 0 and 1. So kind of like our last one here, we got to, before we do that antiderivative, we got to distribute that. So that's going to become u squared minus u to the 4th. One thing I'm going to do here too, I notice our limits here, usually we have the smaller one on bottom, bigger one on top. So I'm going to switch these around. Remember what that does is change the sign. So now that would change this to positive if we just made that switch there. So now our antiderivative would be u cubed with the reciprocal 1/3 minus 1/5 u to the 5th, evaluated at 1 and 0. This one, we don't have to substitute back in because we changed those limits, so now it's just plugging those in. If we put in 1, it'd be 1/3 minus 1/5. If we put in 0, both are 0. So now we just got to figure out what's 1/3 minus 1/5. Get a common denominator, which would be 15. So 5/15 minus 3/15. And the final answer is 2/15 would be the exact answer on this problem.